So, as usual, homework becomes notes. Mr. Myers, we never have enough time to review at the end of the year. Why don't you do a review at the end of the year? I wonder. Oh, well. So, of course, you know that you have an X, you have a Y, and you know that I have to be parallel to that line. Because you know you are parallel to that line, what do you know? Since nobody bothered to do it for homework, we will treat this as if it were homework. So if you were doing this when you were supposed to do it, which was yesterday and last night, you would have said to yourself, self, what does that word parallel tell me about the line which I must use? Corey?
Exactly beside the line that we have?
Right. So you have the point on a new line, but a point is not enough. You must also have what? A slope. And parallel tells you that the slope would be the same as this blue line. So what then is the slope of this blue line? How do I find slope? Isolate the y. Once y is isolated, whatever number is with x is your slope. Negative 2x, y equals negative 2/4 x. Why do I not care about the 7? Because that's a y-intercept. I only care about the slope. What is the slope of the line that I have? Which is negative 1/2. Now, do I have a slope and a point?
Yeah.
What is the slope? No. The slope is negative 1/2. What is the point? So what form uses slopes and points? The one called point-slope form. I'll remember what point-slope form is, Mr. Myers, so you look on your list. Where does the coordinates that we know go in that form? Where y1 and x1 are. So it is y minus y1. What is y? 1. So it's y minus 1 equals m. What's my m? Negative 1/2. X minus x1. What is that?
Plus 3.
X plus 3. But why is it plus 3 when it quite plainly shows a negative there?
Minus 3.
Because it is x minus 3, which gives me a positive. Now that you have all seen how to do it, do number 8 as classwork that should have been homework. Again, you have all the information you need. You have an x and a y to give you a point, and you can find the slope that you care about. But it is not parallel this time, it is perpendicular. Before you can carry on. Isolate y. 8y equals negative x. Do I care about the 5? No. Y equals negative 1/8 x. Is that the slope I want? No. Why not? Because it has to be perpendicular. So what do I do to that slope? To 8. Now, do I have a point and a slope?
Yes.
So what is the equation?
Y plus 2 equals to 8 x minus 2.
Yep. Y plus 2 equals 8x minus 3. Lovely. I have 5 lines there. Those 5 lines all have an equation because every line has an equation. I would like for you to tell me the equations of those lines. Again, nobody has done it, so go. I will remind you that your best friends here are y equals mx plus b if certain conditions are met, and y minus y1 equals mx minus x1 if certain other conditions are met. If you do not know what those conditions are, then you will want to pay very close attention when I go over it. There will be a black line, a red line, a blue line, a green line, and a gray line. They are lettered as well. All right, what form are we going to use for A? Can I find a slope for A? Of course I can. How? Rise over run. So I pick any 2 points, and I count rise over run. I would use that point and that point. Why did I choose them? They're precisely on a corner and they're far apart. My rise was 2, my run was 2, 4, 6, 8. So what is my slope? Which is 1/4. Do I also have 2 points? Which point do I want to use? Or can I use any point from the line? I could also, there's a point right there. Can I use any point from the line, or must I use one of those specific points from the line? Is it called one specific point slope form, or is it called point slope form? Point slope form. So I'll ask a third time. Can I use any of those points? Yes. The only thing I need to do is know their coordinates. What are they? -2, 3.
2, 4.
What are my 3 options? So give me one of them. So what would the equation be? That is one correct answer. Excellent. What is the next correct answer?
Y minus
That is the second correct answer. What is the third correct answer?
Y minus 5 equals 1 over 4 bracket x minus 6.
Excellent. That wasn't too difficult. They are all the same thing, which bothers math students because you say, how can they possibly be all the same thing? If we got rid of the brackets and we collected the like terms, what would you see? The exact same numbers. Now, let's see if we can cut that down to under 5 minutes when we do B. Go. I want something.
Y plus 4 equals 3 over 2 x plus 4.
Okay. What's the second answer for that?
Y plus 1 equals 3 over negative 2 x plus 4.
You needed a negative in the first one because it's a negative slope. What is this? What is C? It's an infinite slope. So
Can we just say x equals 2, 5?
x equals 5. Excellent. What is D?
Y equals to 9.
Y equals 9. And what is E? Pardon me?
7 over 2x minus 6.
Y equals 7 halves x minus 6. 1, 2, 1, 2, 3, 4, 5, 6, 7. Yep. Except it's 2 over 7. Yay! Turn your page over. Now we can go back to what everybody loves, which is, yeah. Okay. What's weird about that equation? There's a K in it. There is an unknown. Why is the k unknown? Because we always know what x's and y's are, correct? If I am trying to find k, what should I do to that equation to make it easier to find k? 3x plus 2y equals k. And I'm trying to find k in every account, yes? All right. So, to find k, I must find an x and a y, correct? Do I have an x and a y? There. I have an x. What is that value? 3. Do I have a y value? Of course I do. What is it? 0. So how do I take that and apply it to that? You plug them in. 3 times 3 plus 2 times 0 equals k. What does k equal? 9. Do that 5 more times. Go. What are the answers? What is k equal in B? Negative 6. What is k equal in C? What is k equal in D? What is k equal in E? What is k equal in F? Yay! Now, listen, please. Turn your books to page. I want to say 229, but check and make sure that page 229 has linear systems in what looks like Flintstone's rock carving. Is that correct? Excellent. That is where we will be working right now. Right meow. Okay, let us discuss systems of equations. before we discuss what a system of equations is, I would like to ask if you can tell me what a system is in general. If I were to tell you I have a system for doing things, what would that mean, Corey?
A procedure.
A procedure. Excellent. If it is a system or a procedure, does it generally happen in one step? No, you go through a routine. Excellent. So a system of equations is indeed a group of two or more equations which may or may not share a solution. Everybody okay? All right. I'm going to give you guys an equation. I lie. I'm going to tell you two variables. You are going to decide which is independent, which is dependent. Your age and the year. Which is independent and which is dependent? Eric. Independent is the year. Why? What did Dana say? Absolutely correct. This year is 2018. Am I alive in 2018? Yes. Are you alive in 2018? Is my age the same as your age? No, thankfully. So, huh? I was thinking the other way around. I would be perfectly happy if you were all 50-something, which is not my age, by the way. I would be perfectly happy if you were all 43, because then I would not be expected to get you to learn anything. We could just sit around and shoot the breeze. But that is not the case. So, if you were to graph that, you would have, it would look like this. Down here would be a year. Up here would be an age, correct? Now, all of you, for argument's sake, even though it's not true, I'm going to say are all 16 years old. This is your 16th year of life. Whether you've turned 16 or not, I am saying you are all 16, yes? Which means you were all born in 2002. Okay? So what would 0 be right here? 2002. And this will be 2018, correct? And age when you were born was what? 0. And your age now is 16. Agreed? And in these 16 years, you have risen 16 years. So it has a slope of 1. Does everyone agree? Because your age equals the years you have been alive, correct? Awesome. Is that a system of equations right now? It's a yes or no question. Read the definition of a system of equations. Do I have a system of equations right now? Some people are saying yes, some people are saying no. Everybody read the definition out loud like in kindergarten. Go. Excellent. Do I have two equations? No, I do not. I have age equals years. That is one equation. Okay? Excellent. So is it a system? No. Good. I'm going to give you a second equation. Driving age. What is it? So how would you write that as an equation? So this, we have age equals years. how would you write the second equation I just gave you? I'll say it again. Okay, well, you can't use A, because A is not always going to be 16. Driving age, great. So let's call D equals 16, correct? Does everyone agree? Now, is that D an independent variable or a dependent variable? Dependent, because you cannot drive until you are 16. So that is, yes, a dependent variable, correct? Which means it would be graphed on which axis? The y-axis. And it would be right here, wouldn't it? Because for everybody, no matter what year it is, your driving age is 16. Agreed? Excellent. What do you notice about that point right there? They intersect. Which means when you are 16 on the black line and it crosses when you are 16 on the blue line, you are now have a point on the graph that fits both lines, yes? And that is the solution. So here is what this means. We're going to do a few more definitions and we're going to get on to it. What is a linear equation? Define it for me. Use mathy terms if you can. As usual, heaven forbid the machine do what it's supposed to do. Once again, nice. Of course. Whatever. What is a linear equation? Don't worry, we haven't just done a whole unit on linear equations. Excellent. Well done. Yeah. So, a linear equation, let's use some more mathy terms in that, a little more mathy if you can, Carl, while my computer doesn't do what it is supposed to do. Because you're absolutely right. Let's try and get another mathy word in there or two. Something is constant. What is constant? The rate of change. That's all I was looking for. Is a relation in which the rate of change is constant. So, if a system of equations is a group of two or more equations which may or may not share a solution, and a linear equation is a relation in which the rate of change is constant, what must a linear system be? A group of two or more linear equations which may or may not share a solution. Now, to solve a linear system means to. If it's a linear equation and it can be put on a graph, what is that graph made up of? Pardon me? A line, excellent, but how do you know where to put that line? X and Y points, yes? So, to solve a linear system must mean to find a set of coordinates that exist on all the lines in the system. Okay? Okay. Let us do that. Today, we are only going to discuss graphing because I want to reinforce graphing because that's what you are testing on tomorrow. What is the easiest form of equation to graph? I like slope-intercept. It's got the fewest problems, it's the least you can go wrong. So, there you go. Step 1 is change the equations to slope-intercept form. What is M? Slope. What is B? The y-intercept. Which of those points is first when I am graphing? Do I deal with the M or the B? I deal with the B. I go to the B value on what axis? And what do I do secondly? I rise, which is in which direction? Up if it's, or down if it's negative. Is there another way that would, or another thing that would make me decide to go up or down? Yes, where I am on the graph, right? If I have a positive slope, but my y-intercept is almost off the graph, would I count upwards? No. And then I look at my what? My run. Right if it's positive, or left if it's negative. How many times must I do that in a system? Yes, must be done at least 2 times or twice. Then identify the ordered pair where the lines cross, which is the intersection. Why is that the right answer? Because it's the XY that exists on both lines. Does everybody feel that they are confident here in what we have said? You haven't done it yet, but does all of this make sense? It should, because you're about to be tested on it in 23 hours. Does all of that make sense? Excellent. Let us go on and make sure. I'm going to use the colors bleu et rouge. And I'm going to run through these. I'm going to do the first one. You are going to do the second one. Let us begin. In blue, is that in slope-intercept form right now? No, so it's a bit of a pain to graph. How would I make it slope-intercept form? Isolate y. Y equals negative x plus 4. Could I now graph that? Yes. What would my y-intercept be? Positive 4. What would my slope be? Negative 1 over 1. Should I graph it now? Why not? I don't know what the other scale is going to be. So I'm going to slide over to red. 2y equals x plus 2. Why did I not move the 2y? My y stays positive. Well done. Now how do I get rid of the 2? Divide by 2, and y equals 1/2 x plus 1. What is my y-intercept? 1. What is my slope? 1/2. Now, are both of my y-intercepts easily graphed on the same scale? Yes. So I can go over to my graph and I can put on my axes. Does it matter where I put those axes? Not particularly. You know, I keep trying like an idiot, 'cause I'm stupid. Other people aren't dumb like me. Other people wouldn't bother. So, I'm just going to drop my hand because I cannot trust this machine. Where does my first blue dot go? 1, 2, 3, 4. What is my slope? What kind of 1/1? So I go down 1 and then right 1. And I can do that all the way along, can't I? And I could do it all the way along the other way, can't I? And I could draw that. Where does my first red dot go? 1. And what is my slope? So I go, would it be better to go up 1 or down 1 from here? 1 up, because I'm looking for where the lines will meet, correct? So 1 up, 2 to the right, and there is where they meet. Since red plus blue equals purple, what is that value? 2, 2. Now, all of you are aware of how many times I have said that you have enough spare time to never hand me in a wrong answer, correct? What does that 2 represent? What letter is that? So what can I write there? 2. What letter does that represent? What letter is that? So what can I write there? 2. Does 2 plus 2 equal 4?
Yes.
Excellent. You would be surprised at how many times I have had to wait for that answer. So, are we correct on the blue line? Excellent. Let us check the red line, shall we, cabbages? What letter does that represent? X. What letter is that? What letter does that represent? What letter is that? Is negative 2 plus 2 times 2, which is 4, 2? Yes. So are we correct on that line? So, would you ever hand this in to me with the wrong answer? No, because you can check. Everybody good? Great. Do it for number 2. Go. Graph them and tell me the solution. I will be doing it here without speaking. It will record. Of course you can.
Thank you.
Of course you can.
Thank you.
If you have an answer, give me the rhino horn. One person, 2 people, 3 people, 3 people. Are you just needing more time, or are you too embarrassed to do the rhino horn? Take more time. I got chocolate.
Oh, thanks, man.
Yes. Do you know the solution to question 2? Then sadly, no.
You actually don't get rewarded for doing what you're supposed to in this class. It's not how it works. I shouldn't say in this class. Maybe you do. I don't know. But not in life. Not the reward to keep your job, generally.
Damn it. It's all right. All right. What's the answer?
Y equals -3/2x minus 6. That's what I got.
No, but I want the answer to the system. I need the x and y, the answer. Negative 2, negative 2? 2, negative 3. Please look and make sure you have done it correctly. Find your mistake if you do not have 2, negative 3, and figure out how you can fix it up for next time. Yeah? Now, we are going to do number 3, but not because it's part of grade 10, because it shows a further property of systems that I wish for you to see. So, I'm going to let everybody have a good long look at 2. It's been recorded. Everybody should be able to see how to do it. Now, let's look at 3. There is a red equation and a blue equation. One of those 2 you should be able to look at right now and be able to deal with. Which is it? The blue one. Excellent. Well done. Something's weird about the red one, correct? What's weird? You haven't seen it before. Those weird vertical lines around the x. Those weird vertical lines around the x are what we call an absolute value symbol. If I told you that I had $10 and Ayla had negative $10, who has more money? Excellent. Good. How did you know that? Because she is negative money and I have positive money, correct? Which means negative and positive tell me a direction or give me a vector. Remember that phrase? Everyone remembers vectors? We use that in Unit 5. Remember, if I took 5 steps to the right, it was positive 5. But we also measured things as scalars, didn't we? Which has no direction. It's just the distance traveled. That's what absolute value is. It is the distance from 0 without a direction. All right? So, before we go any further, just quick little, there's 0, there's 10, there's negative 10. In a moment, there will be negative 10. A slightly longer moment there. This, in vector terms, is negative and this is positive, yes? In scalar terms, how far away from 0 am I? 10. How far away from 0 am I? 10. So the absolute value that I have traveled on the x-axis is how far, no matter what direction I go? 10. Is everybody with me? Okay. So now, come over to here. Let's graph this. If those absolute value lines weren't there, y would equal x, correct? So I input some x values and I'd get a y value. If I input 5, what's my y value? 5, because it says x equals y, correct? What if I entered 0? 0. Excellent. Now, those lines are there. So if I entered negative 5 for x, am I allowed a negative inside those? Was that negative allowed? No. So how far away from 0 is negative 5? 5. So I would go back to 5. Is everybody with me?
Oh, okay.
Everybody cool?
Yeah.
So what if I put negative 7? What would the y be?
7.
7. What if I put 12? What would the y be? 12. What if I put negative pi? What would the y be? Positive pi. Is everybody good? Now, how many points do I need to make a good graph? 3 to 5, right? Do I have my 3 points? Okay. So I'm going to come over here. I'm going to make me a graph. And remember, this isn't part of grade 10, but I'm showing you a pattern of systems that I would like for you to understand. Let's put our 3 red dots on there. 0, 0. Cool in the gang, right? 5. 5, 5. Everyone agree? So what's that slope? You can obviously tell it's going up by 1. Yes? And since there's no exponent, even though those absolute value symbols are there, I know that it's a straight line, don't I? Because there's no exponent. What's happening on the other side of 0? When I go to negative 5, 1, 2, 3, 4, 5, where do I go? I go back up to 5 and I make this construction.
It's right there.
It is right there. It is part of Insane Bryce's House of Graphs. All graphs on sale this week and this week only. Buy 2, get 1 free. Because he's crazy. Everybody cool? Is that a line on a graph?
Yeah.
Excellent. How do I graph the blue one? Where do I go? 3 where? 3 on the y-axis. 1, 2, 3. Then what? Up 1, right 2. Then what? Up 1, right 2. Then what? Up 1, right 2. And what do I see? What happens there? An intersection, yes? But what do we know about that blue line? Doesn't it go the other way too? Doesn't it also go down 1, left 1? 2? And what do I see there? Another intersection. So, how many solutions does this system have? 2. Does everyone understand? You may graph things that cross more than once, which means you have more than one solution. Everybody with me? Let's check them. What is this value? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6, 6. Agreed? What is this value? Negative 2, negative 2. Sorry, negative 2, 2. Does that work?
Yeah.
Of course it does. Because negative 2 is the x value. Is the absolute value of negative 2, 2? Is it 2 steps from 0? Yep. Is the absolute value of 6, 6 steps from 0? Excellent. Is half of 6, what is that?
Half 6,
3 plus 3? So 6 equals 6. Are we okay there? Is the absolute value of 6, 6? Yes. So we're okay there. Does everyone understand? What if my graph looked like this green line I'm about to draw on here? Are there any solutions to that system of red, green, and blue lines? A solution, remember, is the xy value that exists on both, or what's a better word there than both? All. Is there a solution to that system as I have graphed it?
Yeah.
Where?
0. No.
Do all three lines intersect at any spot? So there is no solution. Do you understand? What if the line did this?
Yeah. There you go.
What is the solution? 6, 6. Does everyone understand?
Yes.
No matter how many lines I have, if they cross at any one point, that point is the solution, no matter how many lines there are. Does everyone understand? Excellent. Now, you have a lot of stuff you could work on right now. You could A, prepare for your test tomorrow, which is on graphing, which is everything up to and including page 216, I believe it was. You can see on the board I've written everything that you have to do. 231, that is this page. I would like to talk about that page Thursday when I am here, because we are going to go over your test, Unit 6 test, and then I would like to talk about this part of this unit. Does everybody understand? And page 231 for Thursday. When I am not here Friday, I want you working on, as you can see on the board, page 224. The assignment from page 224, which looks as such, is due Monday. So you can work on it Friday. I know we're kind of all over the place, but it actually makes sense if you step back and take a longer view of it, correct? I do not care in what order you work. What I do care about is on Friday, when you are in this room with Mr. Sagert, you are not giving him a hard time because he is doing me a huge favor. Okay? That is why I'm leaving you with so much you could possibly be doing. Everybody cool? So do it. Don't give me that line of horse crap on Monday that you did not have time to do page 224 for marks.
We do 224 to 227.
Because that is a lie. 224 to 227 is the assignment that is being marked on Monday. You will work on it on Friday. Okay? Now, if you're really lucky, my good friend Bryce will be here on Wednesday and Friday. I don't know if he will be, because he is here out of the goodness of his heart. If he were to show up on Friday, he could assist you, because he can kick this stuff's ass. If he were to show up Wednesday, he could assist you. But it's a test, so you shouldn't be asking anyway, should you? Everybody understand? Let's pretend you're not here for Wednesday's test, like 5 or 6 of you aren't going to be, like 5 or 6 of you aren't every time I give a test. you will be writing it on Thursday. If you do not show up on Thursday, don't expect to write the test unless you bring a note from Mummy or Daddy as to why you missed test days twice. Clear? If you don't write the test Wednesday or Thursday, you will only have one chance to fix the test, which is the cumulative. And those of you who have yet to figure this out, the cumulatives are more difficult. Why? Because you have had longer to get ready for them. So if you wish to put all your eggs in one cumulative basket, by all means do not show up. Okay? Okay. And I remind you also of this. I am cruel. If you have wasted my year, I got no problem assigning you another whole one in this room. Okay? Okay. Go.
I wasn't really paying that much attention. Did you